represents the length of our IP header. IP header is a variable header. Everyone can see. Here is a 20 byte. 1B equals 8-bit. Everyone should know about this conversion relationship. 8 is 8010100101. Binary code like this. This is called a. Our 8 binary bits are called a byte. So the length of our IP overall header. It has a fixed length of 20 bytes. There is an option behind. But it's basically useless. If options are added in the future, then it will take up some digits. Just understand this. DS field is a differentiated services. It has another name called DSCP. You will use it later when you learn IE. We don't need to pay attention to this thing at all in the NA stage. This is a total length. The total length represents IP header plus length of upper layer data. That is the total length after the network layer encapsulation. Some students will ask, isn't that the total length of the message now? Not really. Because we want to add the head and tail of the second layer. So actually the total length of the 3 layers here. I mean the middle. Also IP header plus upper layer data. This is enough to understand. Further down there is an ID number. A flax. A fragment offset. So let me briefly explain their concepts to you. We will mention something called sharding here later. When the data packet is transmitted on the link, the carrying capacity of the link is limited. For example, I want to send a data. Let's list it now. For example, here are a few devices in the middle of me. Draw some links between us. Then these links. Finally, the data message must be transmitted. Suppose I want to send an upper layer data now. The size of the upper layer data is 6 kilobytes. That for us. There will be a value on the link called MTU. That is the maximum size of data packets that a link can carry. By default, if we don't modify it, the MTU value on the link is 1500. Then this MTU. In fact, it is for our data packets. That is, the 3-layer packaging is completed. What we can carry by default is 1500. Then you said that now I have a 6000. Such a data. If I go directly from the link, can't move. It's like a bridge. A maximum of 1500 people can walk on this bridge. You now have to have 6000 people walking at the same time. Walk this bridge. That bridge can't carry it. You have to stand with so many people. The bridge is broken. But for our data communication, if you come over, you have to leave. Then you can't actually go. I won't send it to you. You can't get your data out at all. Now we have a method. We can divide this 6000 into 4 pieces. For example, divide it into 4 pieces of 1500. Then send it out 4 times. This is a sharding mechanism we are talking about. Can you understand? Equivalent to if the upper layer data is too large. We are at the network layer at this point. You can perform a slice of the data. Cut it into small pieces. Then divide the hair piece by piece. Then, for this sending process, it will have some doubts. We have to consider some problems in the sending process. For example, first question. I will give you an example. I have this device. The first device is sent to the 4th device. Suppose I am the 4th device. If in the future, I will provide services to a very large number of users. Every day a lot of data will be sent to me. So now the data you sent me. How could I know? This is the data sent to me by your device. You also send me more than one at a time. How do I know you sent me a set of data? Because now a lot of data is going from me. How do I differentiate this device? The 4 data you sent need an identification. You have to identify. The data you are sending now is a group. So before the future data is sent, divide the data into a slice locally. Add the same ID to it after sharding. This is called an ID number, equivalent to adding an identity. Let's say 4 ID numbers. Add a 100. Represent now. This is my device. Produces a set of sliced data. You need to know when you receive it later. This is what I sent you. And divided. Then for such a shard. In terms of our entire network layer now, what it uses is this identification. Identification by such an ID number. Identifies the future I, which is a set of data. It is good. This is point 1. 2 ND. We will now have another problem. I'm going to send you shards now. But after you receive this shard, how do you combine? Let's take an example. Like you posted a movie. This movie has a beginning, middle, climax, and end. How do you know which slice is on the head? Which one is at the end? Which one is in the middle? And you see, I just now have device 1. My device 1 has been sending data to this device 4. I as a terminal. How do I know when you're done? I am a receiver device. You keep giving me ID numbers. Indeed, I see you, this is a set of numbers. But when will you finish it? When do I start reorganizing here? How do I piece the data together? We still have a logo. Then in our whole, it will have a new function. Then in this function, it exists in this flags. There will be a shard. That is, there is a MF and a flag bit. Indicates whether there are any shards behind. If there is no fragmentation displayed in this, then the peer device can start to reorganize. Can you understand? The last has a slice offset. What does this mean? In the future we send data. Everybody needs to know. There will be an out-of-order problem. I send data. I send it to you once by 12:34. But when you don't necessarily collect it, it's 12:34. Data in the process of network transmission. There may be some out-of-order issues. There is some delay. Then what you finally receive may not be charged according to 12:34. So now there's a feature to reassemble the received shards in order. Then there will be a number. Like, what do you mean? We are still for the offset just now. Is it divided into 4 pieces? I can make the first block represent 1 to 1499. This is 1500. The second, from our 1500 to 2999. Do you understand me saying this? So take our 0 and 1500. Can be offset when we a shard. It's like starting with 0. And then 1500 starts. Further down, it starts with 3000. It is good. 3000 starts down. Further down is the beginning of 4500. Then mark everyone when you come over. You are this 0. That is, you are the first paragraph. You are this 1500 is the second paragraph. You are this 3000. You are the fourth paragraph of this 4500. Everyone needs to come. Indicate which segment of the entire data you are in. After reaching the opposite end. Since we have just discussed